I just will take the time to solve questions which was asked in the last week. So yeah, the coming days you could study. You could take this time for studying and for preparing your final exam. Since we finished all the classes, we don't have anything to repeat. So the coming classes you could study by yourself. Now here,
Doctor,
today's,
excuse me.
yes.
Doctor, in the tutorial 4, you have solved all the question, 10 question?
Yeah, all the questions for regular classes, but for part-time will continue tomorrow.
Okay,
Not
because yes,
tomorrow, not tomorrow, on Thursday. For part-time, I will continue.
yeah, there's
I
still, I
think for
think, two questions.
part-time, I finished 2 questions, right? The remaining questions, I will continue.
Yeah, that one, because when I
Yeah,
check the
yeah,
videos
yeah,
which you
yeah,
shared,
yeah, yeah. Yes, yes. For part-time, yes, absolutely correct. For part-time, 2 or 3 questions are remaining. That I will finish on Thursday, last class.
great, Doctor.
Okay. So today's class, just I wanted to explain to you on the questions which was asked. The exam, the question was here, like you have a welded joint here. This is the welded joint, and the welded joint consists of this is a welded joint, and it consists of defects here. This 2 defects are here. The thickness of the welded joint is 10 millimeter, and it consists of the metal, the alloy. What are the elements in the alloy? The alloy consists of titanium, 10% magnesium. So 10% magnesium and 15% molybdenum. So questions are different for different people, but just I will I just took a sample and tried to explain. So 75% titanium, 10% magnesium, 15% molybdenum. 75% titanium. So here, you know how to calculate the, I am not going to explain, you know how to calculate um, absorption coefficient, which is mu for the alloy and rho for the alloy. Rho is the density. So density and absorption coefficient, you know how to calculate them. So these two are calculated and I got the values as, for example, here 3.984, unit is megagram per meter cube. You know how to calculate it because I have seen most of the answers were right because of this, correct? Okay. So these are the basically density, and then this is megagram per meter cube. So you have these two values, mu and rho. Now the question is, what if you pass X-rays through it? It will come out. It will fall on an X-ray film. Can you detect these 2 defects? What are those defects? First defect is molybdenum. So here, molybdenum is one of the defect, which is 0.5, and this is another one, which is lead 1 millimeter. So these inclusions are there, and how, whether we can detect using X-ray. So the first question was mu and rho that we calculated. Second is the X-ray is passing through a perfect weld. So how to calculate the X-ray passing through a perfect? Imagine there are no inclusions here. There is no inclusions here. How to calculate it through perfect? Ix over I naught through perfect equal to e raised to minus mu rho x. Can you see it? Something happened suddenly. Okay. So here e raised to minus 3.984 times 20.135 times thickness of the material is 10. So 10 times 10 to the power minus 3, which is 0.4484. Now I will calculate. This is the second part of the question. Third question was calculate through the defect. So if I want to calculate through the defect, how much is through the defect? It is e raised to. First step, I need to use e raised to minus mu x is the equation. So 20.135 times 0.0085 plus again minus 10.2 times 79 times 0.005. So this one, okay, then plus what is the remaining things? Minus 11.34 times 350 times 0.001. I will explain to you what is this. This term corresponding to 1 millimeter lead. Look at that, 1 millimeter lead. This correct, and this one, so 1 millimeter. This one, this one corresponding to 3 zeros are there. This one corresponding to 0.5 millimeter molybdenum. So this is molybdenum and this is lead. Lead is Pb. And this one is the normal alloy. Normal alloy.
But doctor, I have question here.
Yes.
From where you get this minus 10.2 and minus 11.34?
Yeah, this one, those who solved the question, they can easily understand. This is material properties, mu and rho. I have given in the question. Those who have solved it, magnesium in a table. I gave the table. Do you remember? Density,
Yes.
mu.
Yes. Yes,
From
I
the
remember
table, directly from the table.
Okay,
So this
so
10.2, yeah, directly from the table. 10.2 is the density, and 10.2 is the
mass?
density. 79 is the absorption
Mass.
coefficient for molybdenum. 11.34 is for lead. This is density. 350, it's absorption coefficient for lead. And this is for the titanium alloy we calculated here. See, directly we substituted here. And 8.5 millimeter. See, you have total 10, right? Total
Yes.
perfect 110. If you remove 1 millimeter for molybdenum and 0.5 for 0.54 lead, yeah, so the remaining will be 8.5 millimeter. So in the equation 0.000085. Is that clear? This is
Yes,
how
ma'am.
I applied the equation through a defect, and I got the value as very low value. Okay. So you are getting something like this in the answer. So when you take the difference between perfect and defect, you are getting a very high value, percentage difference when you take that. You know how to calculate percentage difference between defect and perfect. If you take a percentage difference, you are getting a value of say 98%. That means you will not be able to detect these defects using X-ray. That is the meaning. You will not be able to, or you will be able to?
Will be able to, yeah?
You will be, yes, we will be,
yes.
We will be able to, yes, absolutely.
Because it is 98.
Correct. If it is greater than 5%, we will be able to detect the defects using X-ray. This is basically the first question. Now, regarding the second question, let me go back and please wait a minute. So this is all about first question. Second question was on second question was on ultrasonic.
Doctor,
Yes.
Doctor, first question, there is a sketch.
Yeah. Sketch means, see, if you look at it.
It will be dark, yes, doctor?
if you look at this, 44 is 44 is, yeah, 44 is coming out, right? Second one, how much is coming out? Only less. That means it will be dark in the sketch.
It will be dark, yes.
Yeah, it has to be dark. Why it has to be dark?
Because it is easily detected.
Yeah, less amount is coming out. Hence, it has to be dark in the sketch.
Yes.
Okay. Yeah. Right. Absolutely right. Then we go to next one, which is on ultrasonic testing. Ultrasonic testing we have. In ultrasonic testing, I asked about like 4, 1, 2, 3, 4. Then this is 3 and this is 4. So there are 4 here: polyurethane, polyethylene, then polystyrene, then plexiglass. Here polyethylene, you have this, then plexiglass, you have this. So this is defect 1 and defect 2. So we have 2 defects here. Can we, at the center, exactly at the center, question is we have to calculate the time required for each one from the ultrasonic testing. We know that when we use ultrasonic, the waves will hit and then it comes back. That we know. It will hit and come back. So let us start this first. I will take this as, I can put it as 1, this as 2, this as 3, interface, back wall as 4. And I can put the defect as defect 1 and defect 2. So T1 means what? T1 is the interface, this boundary between polyurethane and ethylene is 2D by V. 2 times thickness is given 15 by V. V is 1.8 times 10 to the power 3. So you get the time for the first one. Did you understand? This first one means ultrasonic waves will pass, it will hit the boundary and comes back. This is first one. Then T2, what is T2? T2 will be 16.666 plus, because I am not going to calculate this again. I will calculate only this here. That will be 2D by V. So 16.666 times 10 to the power minus 3 plus 2 times D. Again, the thickness here, again, it is given as 15. So this is 15, this is 15, and the remaining are remaining 2 are there, 10, 10 each. So 2 times 15 divided by V, 1.9 times 10 to the power 3. So you get 32.455 times 10 to the power minus 6 seconds. Now T3 time from the third is here. I don't need to add all of them. I just add this one, 32.455 times 10 to the power minus 6. I will get until here. Then I need only this to be added. So 2 times 10, thickness is 10 by velocity of. But one thing you have to be careful here is selection of velocity. You should select the velocity appropriately, because the velocity of polyurethane should be selected here. And the velocity of polyethylene should be selected here. Velocity of sound through polystyrene should be selected here. And the final one, T4, is the final one. It hits and then come back. The final one hits and come back is 40. When you add this, you get a 40.788 times 10 to the power minus 6. So the last one will be 40.788 times 10 to the power minus 6 plus the last one again 10. The last one is 10 here. 10, 2 times 10 by velocity through plexiglass is 1.7 times 10 to the power 3. If you look at it, you get 52.55 times 10 to the power minus 6. So we didn't finish because we calculated only through the boundaries or interfaces. Now we have cracks or defects. So let us start with the defect 1. If you calculate defect 1, how to calculate defect 1? So how to calculate defect 1? Defect 1 is at the center of this. So I will take the first one, 16.6666 times 10 to the power minus 3 plus 2 times. Defect is at the center. So 15 by 2, 7.5. Why 7.5? Because it is at the center. So 15 divided by 2, 7.5 divided by polyethylene. Polyethylene, if you remember how much, I think 1.9 times 10 to the power 3. So you will get a defect 1. Okay. And then defect 2. Defect 2 is also here is defect 2. So I will take ultrasonic waves to hit here. That is T3. T3 is, I calculated T3 as 40.788 times 10 to the power minus 6 plus defect 2, then plus 2d, 2 times 10 divided by 2. 2d, d is depth, 2 times 10 divided by 2. So we get 40.788 times 10 to the power minus 6 plus 2 times 10 divided by 2. So 10 divided by 2 is 5. And also the velocity is how much velocity? The last one velocity is 1.7 times 10 to the power 3. So we get the value as 46.67 times 10 to the power minus 6 seconds. Do you have any doubts in this? You can ask, or otherwise I can proceed.
No, Doctor, thank you.
Clear,
Yeah.
Doctor.
Okay. Now the last one is sketching. This is how do we sketch it? The first one, when we sketch it, so here if I can explain, I will draw a small figure here, or I can. The first one will be from first echo will be initial pulse from here. This is initial pulse. Second one is from 1. I will write just 1 only so that you can understand. This is maybe initial pulse. Then from 1, this is 1. Then this is 2. Then 3. And 4. Remember, 4 is the back wall. Now I can write the values here. T1 16 point minus 3. Then here T2 32.455 minus 3 or minus 6. Sorry, it is minus 6. And here 40.788 minus 6. And the back wall 52.55 minus 6. Now here, these are the curves. Now, in this equation, we forgot defect 1 and defect 2. We need to include defect 1 is between 1 and 2. So it must be a smaller echo between 1 and 2. This is defect 1. What is the time for defect 1? You have to write 24.56 times 10 raised to minus 6 seconds. Defect 2 comes here because why it comes here? Because it is the middle of this between 3 and 4. So this is defect 2. And the value is 46.67. And 6 seconds. So this is called as sketch. Sketch the diagram means you have to draw like this and you have to enter all the values here. Then only it becomes sketch. Okay. Clear?
Clear.
Yes, yes, Doctor, clear.
Okay.
Yes, Doctor.
Clear,
It's clear.
Doctor.
Okay. Okay. So thank you very much for attending.
Doctor,
Yeah, for part-time. Yeah. Yes, please.
yes, when it comes to sketching,
Yes.
the height of each
Yeah,
box
yeah,
should
yeah,
be the
definitely.
same
This question, height of the crack must be less, as I have shown here. And as you progress, the height has to be reduced.
or reduced.
Yes,
All right.
because the attenuation of sound waves. Okay.
Okay, Doctor. Thank you.
Okay, Doctor.
Okay.
Doctor,
Thank you. Yeah.
you will share with us the mark of 15 or 50 before we enter the final?
Yeah, of course. By next week, you will be able to see the marks. Sure.
Okay. Yeah, so we have submit only
Reports.
three lab reports.
Only 3 lab reports.
Yeah, that will be out of 25. Okay.
Yeah, absolutely. Out of 25. Yeah. Majid, do you remember till which question we solved that time?
Yes, Doctor, we have solved. Yes. If
Which
you go
one?
back.
I think I finished
No,
this.
Yeah, this you finish it. Okay.
Then we have the new cantilever beam force measurement.
Yeah, this
one?
we did not finish. Yes.
We didn't
This is
start
one.
this. Yeah.
Yeah, this is one. And the other one is number 2.
2 and 3.
Yeah, 2 and 3.
If you want, yeah, if all are here, then I can explain this again.
I don't know, Doctor, if all of my colleagues there are here is present this lecture or not. So if they're here, if we can take one question now,
okay,
it will be better.
Okay. So this one is just if anyone wants to leave from full time, you can leave because I already explained to you about this. In the previous classes, we finished all the tutorials. This is just for some part-time students. Only the few questions need to be solved. That's why I'm just repeating for them. Okay.
Okay, Doctor.
Yeah. Full time. Any student, if you want to leave, you are always welcome. You could leave now, no problem. Part time could continue, so that I could solve this question. Okay. Yes, Majid. This question is determination of force using a cantilever. Cantilever, one end fixed and the other end free, and a force is applied here. This is the force applied. So the height of the cantilever, the width is 0.8 millimeter. The width is equal to 2 millimeter. Length L equal to 25 millimeter. So length, width, etc. are given. Height also given. So here, what is the question? Determine the spring constant. What is the value of K? It acts like you might be wondering, is it like a spring? Yes, any material, especially metals, they will act like a ductile material. They will act like a spring. If you apply force and remove it, it will come back to its original state. So it will look like a spring, more or less a spring. So if the lengths are subjected to uncertainties of 0.5%, determine the percentage uncertainty in the estimate spring constant. What is the force if the deflection of the free end of the cantilever beam under a force acting there is 3 millimeter? So here we need to find K1 and then we need to find the force acting if the deflection delta is 3 millimeter. And uncertainty we have to calculate. These are the 3 things we need to calculate. Whenever we apply a force to this material, the length, width, height given, what will be the spring constant K? What is the force if the deflection is 3 millimeter, and how to calculate uncertainty? Here the parameters of the material are given, modulus of elasticity given, width given, thickness given, length given. So we know that the moment of inertia I is equal to bh cube over 12 or bt cube over 12, any equation you can use. Width is 2 millimeter. If you convert millimeter to meter, 0.002 meter times thickness is the height. So width is, this is b, the width, and this is thickness or height, 0.8. So 0.0008 cube, because you convert millimeter to meter divided by 12. So you will be getting it in meter raised to 4. Now from lecture notes, I explained to you, it says rectangular cantilever beam, the equation for K is 3 EI over L cube. E is modulus of elasticity. You have to use this modulus of elasticity, 3 times 200 times 10 to the power 9 times I. I we calculated here, I is here, this is I is 8.5 times 10 to the power minus 14 divided by L. What is L? L is the length, 0.025 cube. So we get the value of K, which is the spring constant K. We can calculate it as 3277 Newton per meter. Now here, the K, this spring constant. This equation is taken from the lecture notes. Okay. Now uncertainty we have to calculate. What is uncertainty? Uncertainty means the error. Now we know that the K, what is K? K is 3 EI over L cube. E constant, 3 constant. For calculating uncertainty of K, delta K over K equal to square root of delta I over I the whole square plus 3 times delta L over L the whole square. This is the equation to calculate uncertainty. Because L raised to 3, that's why 3 times delta L over L, the whole square. But delta I itself has some uncertainty. As you see here, I is bh cube over 12. So delta I over I means delta B over B the whole square plus 3 delta H over H the whole square root of. So that is first step, you find delta I over I. And in the question given for the width is 0.5% directly in percentage. 3 times 0.5. So you will get 1.58% as delta I over I. That delta I over I is substituted here to find delta K over K, which is 2.18%. Any doubt, any questions in this you can ask? Because in order to calculate delta K over K, you need delta I over I. So delta I over I is calculated from here and then substituted here to get delta K over K. So you got delta K over K. From here we can calculate K, which is equal to 3277 plus or minus 71.4 Newton per meter. So F is equal to KY. So F is equal to K. K is 3277 times Y 0.003. So 9.83 newtons is the force. So that there was a question here, 3 millimeter. 3 millimeter is cantilever beam and the force acting there is 3 millimeter. So here directly F is equal to KY, you have K and we have Y, just multiplying them, we get 9.83 Newton. Any questions, please? Or it is clear?
This equation would be given or no?
Yeah, these equations are already there in the lecture notes. We use the equations from the lecture notes directly. Because now the equations will not be given, you take it from the lecture notes since it is open book.
Yes.
Okay.
Yes.
Any questions, any doubts here, or it is okay? I can proceed.
It's okay.
Okay. Now, yes, I will solve one more question before we leave, so that we'll have. Yes, this is another question given here. An accelerometer has a mass. This is the mass. Mass is 0.02 kilogram. Spring constant K 2000 Newton per meter. So it vibrate. We need to find the acceleration of a particular, for example, a vibration. So we fix a table to the body, to the body at which we need to find the vibration. The body, as the body vibrates, the table also will vibrate. We connect a spring to the table, and spring is attached with a mass of 0.02 kilogram. As the body vibrates, the spring also, what happens is, because of the mass attached, there will be a movement of m mass. So this movement, we record it as 1 centimeter plus or minus 1. So up to and fro movement. So it moves in this direction and in this direction depending on the vibration. So question is, what is the acceleration? Acceleration means, what is the acceleration? Acceleration. So F is equal to m times a. Acceleration is force by m, mass. We don't know the force, correct? How can we find the force? Or how can we find the acceleration? So force has two equations. If you look at it, force is ma, mass times acceleration, equal to k delta x. Spring constant k times delta x is the displacement. So acceleration can be written as k delta x over m. Look at that. Here I have written it. So acceleration is k is given, delta x is the movement 1, and m mass is given. We get acceleration from here directly. This is first question. What is the acceleration? Natural frequency can be calculated using the principle of vibrations. So 1 over 2 pi square root of k by m. K is the spring constant, m is the mass. Just key in the values directly, you will get the natural frequency in hertz. Natural frequency in hertz. So the equation, the answers are given here, k delta x over m. Then from here you get acceleration, and natural frequency. From here you get the natural frequency. Okay. Yes.
That's it only, Doctor?
Yeah, I will finish this also. Huh? That is better.
Okay.
Is that okay?
Okay.
Yeah,
Okay.
this will not take much time. So an engine, we have an engine, we need to know what is the power produced by the engine or torque produced by the engine. So for that, what we do, we use a brake drum dynamometer. It has a brake shoe like this, and when you apply load here, what happens? The braking will increase, and finally the flywheel will stop. At the time of stopping, the torque produced can be calculated. How? The torque produced at the time of stopping will be equal to the force or the weight you applied here times the torque length. So force times length will give you the torque. So this is a widely used instrument to find what is the power of an engine or a torque. There are different dynamometers like eddy current dynamometer, hydraulic dynamometer, etc. This is a mechanical kind of dynamometer. We call it as brake drum dynamometer. Now in this dynamometer, we have a power given, which is 5 kilowatts. No, we need to design. This question is slightly different. We need to design a dynamometer, means we need to find torque arm length. So how to find torque arm length is, first step we have power. So power is equal to 2 pi nt by 60. You know that equation for power. So power is equal to 2 pi nt by 60. So 5 kilowatts is the power, 2 pi n is the speed, 1200 RPM times t by 60. Torque, from here you get the torque value directly from here. How much is the torque? Torque, you are getting it as 39.79. If you need not to consider the efficiency, 39.79. So once you get the torque is equal to the force applied times the length. So you have torque here. The force applied is given in the question. How much is the force applied? Can measure a maximum force of 100 Newton. So torque 39.79 equal to 100 times L. From here, you can find the torque length L. Here they have considered an efficiency. They multiplied 0.9, 90% efficiency. So it becomes 90 Newton. And then they calculated the remaining. Even if you calculate it without efficiency, it is okay. Calculate it for 100 Newton and calculate the length. And that's it. The length is, torque arm length is 39 millimeter. 39 centimeter. Yes. That's it. Clear? So we calculated, calculated torque, and then from force is given, calculate the length from here. That is the question. So we finished all the chapters and all the tutorials. Okay. So thank you very much for attending. And
Doctor.
yes.
Doctor, now we can see it's there is many things will come in the exam. There is any things you will delete it, or all the things we
see,
I have studied?
I can the most of the things are included, but I can guide you in something like the chapter of introduction to NDT, number 1, chapter 1, introduction to NDT, and
you mean week 1?
Week 1
yes.
And penetrant, if you remember, penetrant test.
Yes, we remember.
Penetrant test, and this can be excluded from the studies. So what are those things I gave you? Right. Introduction.
Still is too much.
Introduction to NDT, correct?
Yes.
Penetrant. Then maybe you can acoustic emission also. The remaining things you have to focus and study.
Acoustic impedance, you mean this?
No. Don't get confused. Ultrasonic is there. No, I am talking about acoustic emission. There is another one. I took it. Okay.
That means
don't confuse it with ultrasonic. Yeah, ultrasonic is different.
That means all the tutorial will be enter the.
Yeah, correct. Absolutely.
All the tutorial which we have.
All the tutorials will be there. Only these chapters are excluded.
Sir.
Yes.
How will be the exam? Multiple choice or some?
No. Similar to the test. You have experience in the test, right? Similar to that.
So no multiple choice.
No multiple. Level 3, we don't have any multiple choice.
That means how many questions, Doctor?
Normally, the maximum of 4 questions will be there for 2 hours. You will get 2 hours and 15 minutes.
15 minutes for submission.
For submission, 15 minutes. So you could easily finish it in 1 hour, 30 minutes.
Doctor.
We hope that, Doctor.
Doctor, we want flexible in the exam. For example, if you write question 1, you can't do back 4 questions.
Sorry, I didn't understand. Can you explain what is that?
For example, if you have 4 questions, I can start to fix, for example, question number 3. After that, back for question number 1. Flexible.
Is that decided by the faculty if whether you can come back or not? That according to the faculty decision, if the faculty says you could come back and you could do this, that flexibility is there, definitely it will be there. Okay, so don't worry about that. It depends on the strategy of the university, not only university faculty.
Okay, Doctor, thank you.
Yes,
we have studied many things in the tutorial, so that all of them it will become.
Yeah,
it's
absolutely.
is too much, too
Yeah,
much.
yeah.
Too much, doctor.
Level
Sir,
3.
Too much.
Yeah, level 3. Level 3.
Yes, doctor, we
Sir,
are
You
level
can't
please
be
3.
help,
not
sir.
master, doctor.
Yeah.
It is,
Please help, sir.
Yeah,
As we
yeah.
are part-time. Please help, sir. For this,
You have to help me first, then only I can help you. You have to help me in solving the questions appropriately. Then I can help you, giving marks.
Okay, doctor,
Sure,
don't
doctor,
worry.
but
Sir,
we
Okay.
sir,
can.
please help, sir. We need
Yeah.
your support.
So I'm always there to support, but if you don't study, how can anyone can support you? You already, most of you finished diploma from other colleges, you know, you know, we are trying our level best to support you in many places. But the
Yeah,
thing
doctor.
is, but the thing is, you cannot give excuse like since I am part time, I will get some. No, you will have to focus. You have to study. This
That
is my
one, doctor.
opinion. Yeah, this is my opinion.
Really, we respect your opinion, doctor. Really,
Yeah,
I
yeah.
appreciate it.
Yeah,
But
yeah, all the
your support also is really I appreciate.
see we see for any case the support is always there, but it
Yes.
only the support we cannot do. The thing is your part is to study, and then
Yes.
our degree programs clearly says that if the student is not eligible for a course or a degree, we should not give it.
Yeah,
So
that
if
one.
the student is not studying and if they don't deserve a degree, don't give it. So
Yeah,
if
that
that
one.
is the case, as I told you, even if you are in my position, the things will be like this. So it is how you can help is you have to work hard. You have to study as a group. Part time, I feel that most of you work in the same place. You could assemble in, I have seen in the first batch of part time who came from Orpik.
Mm,
Who came from Orpik.
yes.
Okay. I have
Yes.
seen them during the exam days before 2 weeks, they sit together in one of the rooms.
Mm.
In
But
one of the
doctor,
rooms, maybe one of their flat, they discuss each other and they study each other and they prepare each other, etc. Now they are your friends. They are still there in Orpik. You could ask them.
yeah, doctor, but in my case, I am alone here only in the company.
Yeah. But what I have seen, Majid, I have seen is we had some students not from Orpik. They assembled near in one of his colleagues' house with the Orpik students, and then they studied. It is not only, I'm not limiting it to Orpik only. All
Yes.
can come, because what I have seen is that time this combined study will help, because one of the problem may not be knowing you, the other one can help you, and you could help
Yes.
when you exchange, when you explain to your friends, your knowledge will increase. You can
You,
it will
doctor,
remain in your brain.
doctor, what's the problem? Last first of the year, we was joined the university, and
Yeah.
it was only 2 weeks. After that, it
Yeah,
started by the online
Y-
studying. We
yeah,
could not
yeah,
make good relationship with the
yeah,
other student and know him.
yeah, I can
Yeah,
understand that, but
if you ask me, I don't have any relationship with the other student because I
absolutely.
don't know.
I can understand that. Now you
Yes.
could make the relationship, and one of the thing is mechanical, even full-time students. Now the practice is little bit reduced, but before the good students like they used to have combined study in the university itself. Part time also they do combined study, but they don't do in the university because they come 4 to 8 only. They do in the other houses. This is just a plan I am giving you. If you couldn't employ now, if you couldn't do it now, maybe later stage also you can do it, because this will be like all will study and all will grow.
It's that, doctor. We hope that, inshallah. We hope that.
All the
We hope
best.
that.
Wish you all
Uh,
the best for this. As
so,
I
doctor,
told you.
you will do the lecture on
Okay, thank you,
Thursday because
doctor. Thank
some
you.
of the
Thank you.
people I think is not present today.
This one this one is already recorded there. They can view it directly from there.
Mhm.
This is already recorded. Still recording.
Okay.
So it is all